a brief about me. My name is Sanjay, and I've been associated with IGC for uh, for past 2 3 years, and I currently teach aerodynamics here. I have finished my masters from IISc Bangalore in 2024, and my specialization is aerodynamics. So my area of work is mostly on experimental aerodynamics and computational aerodynamics, CFD and all. So yes, that's in brief about me. So now let's get started. Okay. So what we are going to do today, this being a demo lecture, I thought let's not take up any new topic which is not so familiar to you all. As I presume most of you are all from mechanical or aero background. Yes. Anyone from any other background apart from mechanical or aerospace? Okay, good. Kevin, you're from CSE. Great. So don't worry. This demo session is just for you to just to understand how the lectures are held in IGC. Okay, and to get to know the method of teaching. So as we head into our regular classes, we will discuss all the concepts in great detail. Okay. So so at least here in IGC, your branch is never going to be an obstruction for you from clearing gate. Okay. So uh, we are all very helpful. Okay. So yeah, what we're going to do today is just discuss some basic concepts of aerodynamics. So I'll just touch upon some important stuff about aerodynamics. We are not going to discuss any topic in great detail. So it is just going to be like a summary of what all are we going to learn in the entire course. Okay. So with that, I'll get started. So let me just ask you guys. I mean, some of you would have already done the course in your BTech or MTech. Uh, so can someone tell me what is aerodynamics? What is your understanding about this subject? What does it deal with?
Here we learn about airflow actually.
You learn about airflow. Okay, good. So you learn about airflow. So is it airflow? Is it an external airflow or an internal airflow? And around what kind of bodies are we talking about? Like this airflow is around what kind of bodies in particular? Airflow around an object. Good, Rahul.
External airflow around bodies like bluff bodies or predominantly
Hmm.
symmetrical bodies, and then we can venture more
Hmm.
into bodies which can produce lift.
Okay, great. So as you guys said, aerodynamics is all about understanding flow past bodies. Okay, so we will be discussing throughout the course. We will focus on flow past bodies. So when I say flow past bodies, it is majorly an external flow. Okay, so you have a body and you have a flow over it. Okay, um, so that is basically an external flow, and you also have an internal flow where the flow is confined by walls. So a flow through a duct, a flow through a pipe. Okay, all that comes under internal flow. So it's not that internal flow is not part of aerodynamics. It is also a part of aerodynamics. But uh, as we deal with applications which are related to aerospace, we are mostly inclined towards flow past bodies, which is external flow. Okay. Now, what kind of bodies are we talking about here? Is it any random body? Like, can I say flow through any, let's say, a sphere, okay, or a cylinder? Are we talking about this kind of bodies, or what kind of bodies are we actually interested in? So, someone just mentioned. So what kind of bodies are we talking about? Flow over what kind of bodies?
Maybe bodies around which the
Hmm?
flow actually meets or tries to meet and does not separate from the
Okay.
get-go. Like we won't be studying flow around a square or something like that, because over that the flow
Hmm.
tends to separate at the starting point itself. So we would be probably focusing more
All
on
right.
objects where flow tries to meet.
All right, Abhiram. Okay, great. So you're partially correct. So it's not that the flow tries to meet. Okay. In fact, you'll see as we dive deeper, um, it happens only in the case of a inviscid flow. Okay. So, but yeah, you are correct. We are dealing with bodies which are more streamlined in shape. What do I mean by streamlined? These bodies are aerodynamically designed. For example, you would have seen, right? A body something like this, which is more streamlined in nature. So, what do you mean by streamlined? It is designed to generate some sort of forces. What forces? Aerodynamic forces. Okay. So, we are going to deal with bodies which produce aerodynamic forces. In our case, which is lift and drag, are known as aerodynamic forces when they are subjected to a airflow. Okay, so we are going to deal with those kind of bodies, but that does not mean aerodynamics is only restricted to streamlined bodies. Okay, you can talk about bluff bodies, you can talk about any irregular shaped body. Okay, so for example, flow through this cylinder, even that is also a part of aerodynamics. But just that, application wise, we are more interested towards streamlined bodies because they produce aerodynamic forces. Okay, so they produce aerodynamic forces. So what are the aerodynamic forces? Lift and drag. So we will learn about these aerodynamic forces in more detail, how they are produced, and how are these streamlined bodies, or rather, how does streamlining the shape, external shape of a body, helps you to generate these forces. Okay, so that is all about aerodynamics. What we're going to study. We are going to get into multiple theories which will help you to mathematically understand how these forces are produced. Okay, we are going to link it to the application, and so this course is mostly going to be theoretical. Okay, and here and there we will see some applications of that. Okay, so yeah, so that is all about, that is in very brief about aerodynamics. Okay, so now let's get started. So yeah, to start with a very simple question: how is lift generated in an aircraft? So what do you see here in this image? This is a aircraft wing, right? It's a wing of a commercial aircraft. So you can see this wing is what helps you to generate lift, and that is the force which um, helps your aircraft to lift off in the air, right? So uh, so how do you think lift is generated by this wing? Anyone? Please feel free to talk. Okay, so more the interaction, more are we going to learn. So how is the lift generated?
Difference in pressure when the flow moves around the body, the aerodynamic
Okay.
forces acting along the body are different. In this case, the upper part
Hmm.
experiences pressure, the lower part experiences more pressure because of the body shape, or which is big and which
Okay,
basically affects the flow, and thus the lift is produced.
good. So as you all know, I mean, even when you ask a layman how is lift produced, how is an aircraft able to fly in the air, right? So the most common answer that we get is pressure difference. So there's a pressure difference created by this wing. Um, so that is what helps you to that is what helps the wing to generate this aerodynamic force called as lift. Okay, so yeah, that is correct, and that is what we generally expect from someone who has little knowledge about aerodynamics. But now, being aerospace engineers, okay, we know aerodynamics in and out, so we should be able to understand it in great detail, right? Or we should be able to look at it in different perspectives. Okay, so if you just cut this wing, if I just take a cross section of the wing, I get a shape something like this. This shape is known as aerofoil, right? It is known as an aerofoil section, which is the cross section of a wing. Okay. Now, why do we have this kind of shape in the wing? Why can I not have any random shape like someone mentioned, like a square or a rectangle? Why can I not have any random shape? Why do I have this kind of particular shape, which is called as an aerofoil or an airfoil? So,
It's with reference with the bird.
with reference with the bird, yes, definitely. So we got the motivation and inspiration from birds. So ultimately, we are trying to mimic the nature, right? So birds fly in the atmosphere, in the air. So we got inspiration from them. How are they able to produce lift? But birds are lighter, so for them, weight is not a great constraint, which is not the case with uh, the vehicles that we make, right? Aircraft is heavy; it's not so light as a bird, right? But still, we are able to fly. So that's due to the lift generated by the so-called aerofoil section, right? So yeah, okay. Someone is saying achieve smooth flow and to reduce drag. Good. Wake is less. All right. So all your answers are correct. So that is all we are going to see in this course. Okay. How does this particular shape produce aerodynamic force? Okay. So if you look at, I mean, in the past, when people were trying to understand how this lift is generated, multiple theories came up. In fact, so I'll not discuss all of them here, but one important theory that came up was a particle theory. Okay, it is very popular. So people said, look, there's an aerofoil. Let's start from the leading edge. So leading edge is the foremost point of an aerofoil. Trailing edge is the aftmost point. Okay, so let's start from the leading edge. You inject two particles. Okay, take two particles and inject one particle. Inject both the particles right at the leading edge. One particle is going to move on the upper surface, and the other particle is going to move on the lower surface. Okay, so now what happens if this is not a symmetric aerofoil? Assume it's, we'll discuss about the types of aerofoil, but for now, just say this is not a symmetric aerofoil. Then what happens? The top particle is moving on one particle is moving on the top surface, the other particle is moving on the bottom surface. So they said, uh, as you can see, the distance covered by the particle that moves on the top, okay, let's call it as particle 1 and 2. So the distance covered by particle 1 is higher than particle 2, which moves at the bottom. Okay, and as someone mentioned, right, that the flow tries to meet. So if you go by that concept that both the particles have to meet at the trailing edge, okay, at the same time, then can I compare the velocities of particle 1 and 2? What can I say about velocities of 1 and 2? Which is higher, which is lower, or are they going to be equal?
One would be higher. One would be higher because it has to
One
cover
would be
more movement.
higher. Yes, good. So u1 is going to be greater than u2. The particle 1 is going to move faster, okay, than particle 2. Now, so this we have compared the velocities. So can I also compare the pressures? Can I compare the static pressure of both the particles or the pressure experienced by the aerofoil due to the movement of these particles? What will happen to P1 and P2? How do I compare them? Yeah. So how is pressure and velocity related, which is that popular equation? Very good, Maushmi. It is P1 is less than P2, right? So how did you say that? Maushmi, how did you say that? P1 is less than P2? What is the logic?
Bernoulli's.
Bernoulli's equation, right? PV is equal to constant. Well, we are not talking about thermodynamic variables here. Okay. Uh, so it's the Bernoulli's equation, right? The Bernoulli's equation relates your pressure and velocity. So it says if my velocity is higher, the pressure is going to be lower because the total head has to be constant. So P1 is going to be less than P2. Okay. So if P1 is less than P2, you can see the pressure on the bottom surface of the aerofoil is going to be higher compared to the pressure on the top surface. So if the pressure on the bottom surface is higher, so there's a surface area, right? So of course, aerofoil is a 2D, two-dimensional uh, view, but the wing is a three-dimensional object. So if you look at the wing, the bottom surface is going to have higher pressure and the top surface is going to have a lower pressure. So that creates an unbalanced force in the vertical direction. Okay, that creates an unbalanced force in the vertical direction, which is what we call it as lift. Okay, all right. So this is how lift is generated, is what was claimed when people were trying to understand about the theory of lift generation. But unfortunately, this theory failed. Okay, unfortunately, this theory failed. Can someone tell me why did this theory fail? What was the flaw in this theory? Yeah, anyone? What do you think was a flaw in this theory? Nobody? Just a guess?
The corollary does not apply. Like if
Hmm.
the wing is inverted, then that does not satisfy the same concepts being presented over here just by the plain Bernoulli's principle.
You mean what is inverted? If the aerofoil was inverted?
Yeah, the aerofoil was inverted.
Yeah, even
Like
if it
it,
is inverted, see, even if it is inverted, you can apply the same logic, right? The particle is going to travel faster or slower compared to the distance traveled, and then you can still argue, right? So
yes.
if this is a positively cambered aerofoil, you invert it, it becomes a negatively cambered aerofoil, right? So it can still generate lift,
So
or it may not generate lift. Yes, yes, Dimanshu.
it was assumed that it will meet at the trailing edge, but it is not possible
Hmm,
every time. So
exactly. Very good. So that was the flaw. Okay. So this theory assumes that both the particles 1 and 2 are going to reach the trailing edge at the same time. Why? Why should they reach at the same time? There was no explanation. This theory could not explain that. So there is, I mean, there is no necessity that they should reach at the same time, right? Particle 1 could reach early, and 2 could reach later. Anything can happen depending on the flow conditions, right? So there was no valid explanation for that. So people just disregarded this theory. They said, no, this is not how we will explain the concept of lift generation. Okay. See, although we know it is due to the pressure difference and it is due to how the airflow is taking place, and we designed the shape of the aerofoil, but this theory was not appealing to people. Okay, to aerodynamicists. So they just disregarded this. So this is one such popular theory. There are other theories as well. We will discuss that later. Right now, I'll not get into that. But later on, a theory that came up was called as circulation theory of lift. Okay, so the circulation theory of lift says if you have an aerofoil, or for that matter, any object which is kept in the air and there's a flow around that object. If you find that there is a certain amount of circulation around this body, okay, we will see what is the meaning of circulation later in our course. For now, it is just the velocity that is integrated around the body. Okay, that is known as circulation. Circulation does not mean that your flow is circulating around the body. No, it has a sense of circulation, but it is not exactly circulating or meeting at some point. Okay, that is not true. Circulation is just a mathematical definition. It means that you are integrating the tangential component of velocity around this body. You get something which is known as circulation. So it is due to that circulation lift is generated, and it was proved that lift is directly proportional to the circulation. So circulation is denoted by this letter called as gamma. Okay, it's a Greek letter gamma. So lift is directly proportional to circulation. This was proved. Does someone know what is this theory known as? What is this theorem known as, which relates our lift and circulation? If anyone has already done aerodynamics. Okay, so this is known as Kutta-Joukowski theorem. Okay, so this we will study in our course later. We will actually derive this theorem, which says lift is directly proportional to the circulation. Okay, the circulation itself is produced due to the airflow, due to the velocity distribution on the surface of the aerofoil, which in turn uh, makes the pressure distribution. So ultimately, we are saying the same thing, that it's due to the pressure distribution, but the way we explain is different. Okay, so it's very interesting to note this. If you read about the early development of aerodynamics, people were actually struggling to explain the concept of lift generation. Even today, that is true. Okay, even today, it is none of the theories can actually give a very satisfying and a convincing explanation. There is some or the other flaw which keeps coming in. Okay, so who knows? Maybe whatever we are learning today might become obsolete after a few years. All right, so keeping aside those things, for us now we understand that there is this shape called as aerofoil. It is a aerodynamically designed shape. It's a streamlined shape which produces aerodynamic forces, lift and drag. Is that clear to everyone? Yeah, clear to everyone till here? Are you all following?
Sir,
Yes, Kevin.
sir, can you explain me in a simple way, sir?
Yeah. Explain what? This concept.
Yes, sir.
I mean, which part do you want me to explain? The circulation that I was trying
Uh,
to tell you now.
that I until that I have some idea that I've observed what you are teaching, sir, and then that I don't
Mhm.
understand what is the those things you are telling.
Yeah, Kevin, don't worry, don't panic. As you're from CS background, you haven't been exposed to fluid dynamics and all other courses for now. So as we get into our regular classes, all these concepts will be clear to you. Okay, so we start from scratch. Okay,
Okay.
so okay, for now I'll just move on because I understand. To explain it to you, I would have to go too much basics. Okay, uh, we'll see that in our regular classes. Fine. Okay. So don't worry. For today, in the demo lecture, you guys just try to uh, just see. I mean, how is the teaching methodology, and you can ask your doubts. So it's just for you to get an experience. That's it. We're going to do all this. Okay. So don't think this is the starting point. In fact, this is not the starting point. Okay. There is a lot of theory which has to be developed before arriving at this point. Okay. All right. So I'll just move. So now we have seen, so I believe all of you, like at least most of you would have traveled by aircrafts, right? Most of you would have flown. So you see wings, right? Wings are the structures which help to generate lift, right? For an aircraft. So there are types of wings. So you wouldn't see the same wing for all the aircrafts, right? You would have traveled by an Airbus aircraft or a Boeing aircraft, or I mean, so yeah, mostly it is either Airbus or a Boeing aircraft, but even then there are derivatives. You would see that the wing, the design of the wing varies from aircraft to aircraft, right? So generally, we find this type of wings. So we have a rectangular wing, which is the most simple type of a wing, very straightforward wing. So you have an aircraft and there's a rectangular wing. Okay. So there is no complications here. We have a trapezoidal wing, which is in the shape of a trapezoid. So remember, guys, when we talk about wings, the wing, it involves both the wings, okay, which is on the left as well as on the right. So we consider the entire wing, we take the length of the entire wing, we call it as wingspan. Okay. If you are referring to only the one half of a wing, it is known as semi wing. Okay. Or half span, semi span, we call it as. So when we say wing, it is generally the entire wing. Okay. And you have delta wing. So delta wing is a triangular shaped wing. You have a swept wing. So swept wing is basically nothing but a rectangular wing which is kind of inclined. Okay. Um, inclined with respect to the uh, center line of the aircraft. Okay, so that is known as swept wing. So the inclination, we generally call it a sweep. It is represented by this lambda symbol. Okay, so then we have tapered wing. So tapered wing is, you just, instead of making a rectangular wing, here the sides are straight. You just uh, okay, you just change the length on any two sides. It becomes a tapered wing. Okay, so you are tapering. There's a linear variation uh, in the width, okay, along the span. So here the image that I had shown you, what kind of wing was this? What kind of wing is this? So what kind of wing do you mostly observe in a passenger aircraft that you normally
So
fly?
it's a swept back wing, sir.
It's a swept wing, okay. And is it a rectangular wing? Is it a swept rectangular wing?
Yes, sir.
It is a tapered wing, right? You can see it tapers. So tapers meaning the cross section changes along the span. So the aerofoil sections keep changing. It is not the same at the root and the tip. Okay, so it's a tapered wing. So generally, we see tapered wing in an aircraft, at least in conventional aircrafts. And there's a reason why do we use tapered wings and why not rectangular wing. So all these types of wing have their own significance. They have their own relevance in the aircraft. It so how do you choose a wing generally? When you do a wing design, when you do an aircraft design, there's a critical part known as wing design. So how do you choose a wing for an aircraft? It completely depends on the mission the aircraft is involved in. If it is a fighter aircraft, the type of wing you would choose is different. If it is a conventional aircraft, passenger aircraft, it is different. If it is a stealth aircraft, the wing chosen is different because you have to minimize your radar signature to have the stealth capability, right? So it depends on the mission that the aircraft is involved in. The mission is very important, and if it is a multi-mission aircraft, when it does multi roles, then again we design it for the worst case scenario. Okay, so all these types of wings have their own significance. For example, can someone tell me any aircraft that uses delta wings? Have you seen triangular shaped wings? Any aircraft? Yes, Ali.
Fighter jet.
Fighter jets, very good. Tejas LCA, yes. Tejas uses delta wings. What kind of wing does B2 bomber use? Have you seen B2 bomber?
Yes, this kind of delta wings.
Yes, that's also kind of a delta wing. So what is B2 bomber? It's a stealth aircraft, right? So why does this shape of the wing vary from type of aircraft? So that we will see. Okay, what is so peculiar about delta wing, about swept wing? Okay, although rectangular wing is a more simple form of a wing, very easy to manufacture, but what why are we not using that, or what are the disadvantages of directly using that kind of thing? Yes, Eurofighter, Rafale, so all these fighter aircrafts, they use peculiar type of wings. Okay, so these are in general the types of wings. So now, so we'll just quickly see some nomenclature about the wings, uh, some terminology uh, which is used to understand the wings. Okay, so you can see here this is kind of a tapered wing. Okay, so let's say if your aircraft is something like this, is your aircraft body. Uh, so the part of the wing which is attached to the aircraft, okay, or which is buried inside the aircraft body, is known as root. Okay, this is known as root, and the free end of the wing is known as tip. Okay, this is known as wing tip. This is known as wing root. Okay, now as this is a tapered wing, you can see the size of the aerofoil used at the root is different from the size of the aerofoil used at the tip, right? So basically, when I say the size, it's the length of the aerofoil. We call it as chord length. So the chord length is varying along the span. So the length of the chord at the root is known as root chord. We denote it by CR. At the tip, we denote it by CT, tip chord. Okay, and at any other location along the span, it is function of the span basically. Okay, all right. So this wing you can see has certain surface area. So the surface area of the wing, which we call it as the projected area, as planform area. Okay, we denote that by capital S. Okay, we denote that by capital S. What is that? It is a planform area. Just one second. So the planform area is the projected area of the wing. So what do you mean by projected area? If I the project the wings on a plane or a paper, the area that I get, okay, is the projected area. So the area of that shape is the planiform area. Is the planiform area which we S. Okay, capital S. So generally, planiform area is the area of the complete wing. It is not just one half or the other half of the wing. It's for the complete wing. Okay, now in some kind of aircrafts, it depends on the manufacturer. If it is a Boeing wing, in some aircraft, you see that the wing is usually buried inside the aircraft body. Okay, in some aircrafts, the wing is not buried; it is just attached. Okay, there's a wing body, wing fuselage attachment, and the wing starts from the fuselage and it goes to the tip. Okay, so in any case, the complete area of the wing is taken as the planiform area. Okay, so we call S as the planiform area, and then there's a span. The length of the wing, right from the left end to the right end, is known as wingspan. We denote it by B. Okay, we denote it by B, small b, which is the wingspan. So the semi-span becomes B by 2, B by 2. Okay, C is the chord. Chord is the length of the aerofoil from the leading edge to the trailing edge of the aerofoil. We call it as chord. I explained you the root chord and the tip chord. Now the ratio between the tip chord and the root chord, we call it as taper ratio. So this taper ratio tells you how is the wing tapered, or what is the extent to which you have tapered the wing. Okay, so it is basically a so what do you see is, what do you expect, the taper ratio is going to be greater than 1 or less than 1? Taper ratio is going to be
Less than.
is it, it is going to be less than 1. Okay, because the tip chord is going to be less than the root chord. Okay, so that is taper ratio, and then there is sweep angle. So sweep angle, as I told you, if you are using a swept wing, which is if your wing is going to be inclined, okay, and so if it is not a rectangular wing, straight wing, if it is inclined to your center line of the aircraft or along this line, if you have an inclination, then we call it as sweep angle. Okay, we denote that by lambda. Okay, now the sweep angle could vary um, along the aerofoil length. So it could be, you could have a sweep angle at the leading edge. There could be a sweep angle at the half chord. There could be a sweep angle at the quarter chord. Okay, so the sweep angle itself can vary. Okay, so there is a reason why we sweep the wings. Okay, which I leave it to you to find out. Okay, so that is going to be homework for today. Find out why do we use swept wings? What is the advantages that it offers, and what is the disadvantages also? Okay, so just read about it. And so if you look at the side view, okay, if you look at the side view of the wing, you see an aerofoil, right? So you see a root aerofoil and the tip aerofoil. So generally they do not align together. Okay, there is always an angle between the root and the tip. That angle is known as angle of twist. Okay, so if your root is kind of higher than the tip, okay, if this angle of twist is positive, we call it as uh, there's a terminology, we call it as wash in or wash out. So wash in is if this angle of twist is positive. If it is negative, we call it as wash out. Okay, these are just terminologies, so don't need to worry. Okay, just for your knowledge. Okay, and why do we twist the wing? Why do you have twist? Because when you twist, you see that every aerofoil along the span is going to experience different angle of attacks. Okay, we will define what is angle of attack. So it is going to experience different angle of attacks. So it will give you a distribution of lift. Okay, so this is about the wing nomenclature. Okay, so some terminologies which is used to describe a wing. So when we refer to a wing of an aircraft, these are the things, these are the parameters which are interesting from aerodynamics point of view. Okay, all right. Is this fine, everyone? Can I move?
This angle of twist is negative in this picture.
Angle of twist could be positive or negative, right? We will see
In
like
this
later on when I come.
particular figure, this is negative.
So
Washout is
so this is washout. Okay, this is washout. So washout in the sense you see that your tip is moving away from the root. Okay, if it is
yes.
moving towards the root, it is washing. So yeah, these conventions are sometimes confusing. We will see that in detail later on. Okay, so again, there's going to be one major problem in the course of the convention. Okay, so I'm going to follow John D. Anderson. Okay, so whatever conventions that Anderson has used, it's a very standard book. We call it as a Bible for aerodynamics. So whatever the convention has been used, we will be using that. We will not confuse. Okay, so if you refer multiple books, the conventions might vary. Okay, so we'll stick to one particular convention. Okay, all right. I'll just proceed. Okay, now let's see an aerofoil. So an aerofoil is the cross section of the wing. As I told you, if you cut the wing and you look at it at the side view, you see a cross section which is of this shape. Okay, so you can see this aerofoil is a streamlined shape, right? So the first point of the aerofoil, you can see the foremost point is known as leading edge. Okay, so you see it's a leading edge, or we call it as nose of the aerofoil. It is a blunt nose. Okay, it has a blunt leading edge. It is not very sharp. Okay, it is not that it is a corner. Okay, we cannot make it as a corner. Okay, the reason you will understand later. It is so we make it blunt for some aerodynamic advantages. Okay, so you see that the leading edge is blunt. Rather, if you go very close to the leading edge of the aerofoil, you will observe that this is kind of a circle. You will get an arc, which could be a arc of the circle. So the radius of the circle is known as leading edge radius. Okay, it's known as leading edge radius. And then you see you take a tangent from the circle and then you extend, you get the aerofoil. Okay, so there's an upper surface, there's a lower surface, and there's a trailing edge. Trailing edge is the aftmost point of the airfoil. Okay, and there's a line which extends from the leading edge to the trailing edge is known as chord line. Okay, we call it as chord line, which goes from leading edge to trailing edge. Okay, and uh, there is you see this green color dotted line, right, which is known as camber. So the camber tells you how much curved is your airfoil. It tells you about the extent of curvature. Okay, so you can have a positively cambered airfoil or a negatively cambered airfoil. So it basically tells you how much is your upper surface deviating from the chord line. Okay, so it is the camber which helps in lift generation. So most of the aerofoils that we use as wing cross sections, they are all cambered aerofoils. Okay, so we have some standard aerofoils. We have a repository for aerofoil, which is most commonly known as NACA aerofoil. Okay, so does someone know what is this NACA? It is National Aeronautics. What is this NACA? Does anyone know? Have you heard about NACA airfoils? You must have heard, right? At least people from aero background. Anyone? Okay, so I think it is something like National Advisory Committee for Aerodynamics. So it has a repository for aerofoil. So there are multiple aerofoil shapes which are very standardized already, and we use them. Okay, so they were used previously, but now if you look at the modern commercial aircrafts, they do not use NACA airfoils. They use their airfoil of their own. So anyone can make their own airfoil, but it has to be certified, right? So anything that you do as a design to an aircraft has to be certified by the agency, right? So we have certification bodies which takes care of certification of military aircrafts as well as commercial aircrafts. Okay, so unless it is certified, you cannot use it. So we have NACA aerofoils. We will learn about them later on. So I told you this camber. Camber is the extent by which the aerofoil is curved. Okay, if it is a symmetric aerofoil, which means the upper surface and the lower surface have very similar curvature. Okay, then we say it is aerofoil with zero camber. So camber tells you how much is the difference in the curvature of upper surface and lower surface. Are they symmetrically curved, or is there any asymmetry in the curvature? Okay, so that tells you, or that quantifies the amount of the quantity of lift produced by the aerofoil. Okay, so chord line and this is known as mean camber line. Okay, this dotted line is known as camber line or mean camber line. Okay, and there's a thickness to the aerofoil. So thickness is basically the distance between the upper surface and the lower surface. Generally, when we say thickness, it could be a local thickness or maximum thickness. So we are always interested in the maximum thickness of an aerofoil because that has some aerodynamic relevance. Okay, so maximum thickness is basically the point above it is measured from the chord line. Okay, so everything that we measure in an aerofoil is always with respect to the chord line. So it is measured perpendicular to the chord line to the point which is maximum away from the surface. So that is maximum thickness. Okay, so there is a location of maximum camber, there is a location of maximum thickness, which has some importance in aerodynamics. We will see that. Okay, so this is about the parts of the components of aerofoil. Okay, which you should know. Any doubts? Any doubts? Anything you guys want to ask? So I've written the same thing over here and not repeat. So you can see that you have a symmetric aerofoil. So symmetric aerofoil is where you have the upper surface and the lower surface will have very similar curvature. Okay, the curvature is not different. Or you can say that it has, if you look at the upper surface and the lower surface, they are at the coordinates are at equal distance from the chord line. Okay, so it is a symmetric curvature compared to the with respect to the chord line. Okay, so we call it a symmetric aerofoil. Symmetric aerofoil is a very simplest type of aerofoil which has zero camber, so it is very easier to analyze mathematically. But do we use symmetric aerofoil in a wing? Do we generally use symmetric aerofoil in a wing? No, right? We don't use because it does not generate any lift at zero angle of attack, right? So we always use cambered aerofoils to get the advantage of lift. So we have when we say cambered aerofoil, you could have positive camber and you can have negative camber. So positively cambered aerofoil, which has the camber line above the chord line. Okay, so if you look at the camber line, it is above the chord line. This camber line is nothing but the average of the upper surface coordinate and the lower surface coordinate. Okay, so if you take the average, you get the mean camber line. So if the camber line lies above the chord line, we call it as a positively cambered aerofoil, and otherwise it's a negatively cambered aerofoil. Okay, so at a given angle of attack, let's say at some positive angle of attack, your positively cambered aerofoil will generate a positive lift, and negatively cambered aerofoil will generate a negative lift. Okay, I repeat my statement. So at a given angle of attack, if it is a positive angle of attack or even at zero angle of attack, the positively cambered aerofoil will generate positive lift, which means you will have the lift in the upward direction, which will aid to fly the aircraft. If it is a negatively cambered aerofoil, at zero angle of attack, it produces a negative lift, which means the lift is going to be in the downward direction. Okay, so that is a negatively cambered airfoil. But do we generally want negative lift? We don't want negative lift, right? We always want positive lift because you need the wing has to produce some lift, right? Only then the aircraft will fly. So we don't want negative lift, but that doesn't mean negative cambered aerofoil is useless. Okay, it also has its own relevance. If you look at some NACA nomenclature for aerofoils, some of the aerofoils you'll find will be negatively cambered. Okay, so they also have their own,
I think
and
while
it is
aircraft in
exactly.
landing,
Just a minute.
we used to need a negative lift, right?
Ali, I'll come to you. Okay, give me 1 minute.
Yeah.
So it is not always that negatively cambered aerofoil generates a negative lift. That can also generate a positive lift provided your angle of attack is very high. Okay, so which we will see when we compare the lift generated by these aerofoils. We have something known as aerofoil lift curve. Okay, so lift curve is the representation of the lift versus angle of attack. So you will see that for a negatively cambered aerofoil, you can get a positive lift, but you have to orient it at a very high angle of attack, which we generally do not do for a commercial aircraft. Okay. Yes, Ali, coming to your question.
Yeah, that one only. Actually, while aircraft in landing position,
Yeah.
landing, so we need
Yes.
to generate the negative lift so that we can able to.
No. We don't generate negative lift. Have you seen how an aircraft lands?
Yeah, with you by
How does an
using
aircraft land?
flaps.
Yes. So while landing, configuration like this, or is it like this? Which is the configuration? Is it first or second?
While landing,
I mean,
high
while
pressure
just
will be on the
touching the
top
ground.
of the wings.
No. While just the aircraft touches the ground, does the nose landing gear touch first or the main landing gear touch first?
Nose.
Are you sure? It is always a main landing
Yeah,
gear. Okay, so it's a
landing
second
gears will touch
configuration.
first.
Yes. Yeah. So you're talking about when it approaches the runway. Yes. At that time, this is the configuration. But this does not mean negative lift to, see, there's always a force that pulls the aircraft down. What is that force?
Sound like
What is
pressure
the force?
force.
No. Pressure is always acting. The ambient pressure acts on the airfoil, but on the aircraft, sorry. But what is the force that, it's gravity, right? So weight is always pulling your aircraft down. So if the weight were not there, will your aircraft fly? No, it will just fall down, right? So you can always come down. Okay. So see, you don't have to give a negative lift configuration like this. Okay, you can just reduce your angle of attack so that your lift is reduced. Okay, and we make use of some devices called as high lift devices which are present on the wing, which gives you more drag. Okay, so it's important to increase the drag. So we don't decrease the lift, but we increase the drag so that it's easier to land. Okay, fine.
Understood.
So you cannot use a negatively cambered aerofoil, because if you use that, will you be able to cruise? Because during cruise, your angle of attack is a positive angle of attack, right? You will not be able to cruise. Okay. So now let's define angle of attack. Angle of attack is the angle between the relative wind and the chord of the aerofoil. Okay, so chord line and the relative wind, that is the angle of attack. Okay. So a lot of people have a misconception about angle of attack. They think it is the angle at which the aircraft is oriented. No. So there are different angles. One is a pitch angle, one is a flight path angle, there is angle of attack. All three have different meanings. Okay. Angle of attack is defined as the angle between the wind or the free stream velocity and the chord line. Okay. So always be careful about the definition. Okay. So you can have two cases. One case is that you can have your free stream velocity is just approaching in horizontal direction and your aerofoil is inclined. So there is an angle of attack which is generated by the aerofoil. This is your alpha. So we call this configuration as aerofoil is kept at an angle of attack. Okay, this is aerofoil at an angle of attack. And there could be a second possibility where the free stream can be at an angle of attack, which means your aerofoil is straight. Okay, your aerofoil is straight, but the free stream velocity or the air that is hitting the aerofoil is coming at an angle of attack. It could be something like this. This is the chord line, and this is the free stream velocity. So again, you see that there's an angle which is the same angle alpha. Okay, so there can be two possibilities. Can someone tell me, does both of these possibilities mean the same? Does it mean the same to the aerofoil? Okay, Yaneshwar, this was
Yeah,
asked in
both
the
are
XC paper.
same.
Both are same, right?
Yes.
So you would have heard that whether a body moves in the fluid or the body is kept stationary and the fluid moves over it, the effect is the same. Okay, because
Yes.
ultimately the fluid is what is helping it to generate forces. The movement of fluid particles generates these forces. So whether the fluid is kept stationary and the body moves through the fluid, or the body is kept stationary and the fluid moves through the body, the effect is the same. So whether you keep your aerofoil at an angle of attack or you keep your aerofoil straight and let the free stream pass through an angle of attack, the effect or the performance of the aerofoil remains the same. That does not change. Okay, that clear?
Second is like Illyrian approach or second
Sorry.
that yeah, body kept stationary and the fluid like free stream is an angle of attack, right? So I think it comes under
Yes.
Illyrian approach. Euler
Yeah.
approach.
So no. See, that is completely different. So Eulerian approach or Lagrangian approach is used to model a fluid flow problem. We mostly model it using Eulerian approach. Okay, Lagrangian approach is
Okay.
not used commonly. We will discuss about it. We'll come to that later.
Okay.
Okay, that is out of point now. So my point here is, I'm just telling you that your aerofoil could be kept straight, but your free stream can come at an angle. It is the same angle of attack. Okay, there is no difference. So please be careful about this, because draw when you draw the when you draw and understand your aerodynamic forces, it's important to note the direction of free stream. Okay, all right. So I hope this is clear to everyone. Okay, so I guess we are overshooting time. So yeah, I think I will just stop it at here. I had many more things uh, to tell you, but for the interest of time, we'll just stop here. We'll just take up one question, okay, and we can end it. Okay, so just look at this question. It was asked in J 2015. Consider a monoplane wing and a biplane wing with identical airfoil sections, wing spans, and incidence angle. Incidence angle is the angle of attack. Okay, in identical conditions in a wind tunnel. So forget about all that. So what this question tells you is you have a monoplane wing. What do you mean by monoplane wing? It is your conventional aircraft wing. Okay, you have an aircraft and you have the wing. This is known as monoplane wing. So it is one single wing. What is a biplane? Biplane means you have two wings, okay, which are connected through struts. Have you seen a biplane? Do you know the first ever aircraft that was developed by Wright brothers was a biplane? Okay, it looked like this. So there are two wings, and this was the aircraft body, and they were connected through struts. Okay, it was a biplane. So you take a monoplane and a biplane, assume the free stream conditions, the orientation, and everything else is the same. How can you compare the lift and the drag? So as compared to monoplane, the biplane will experience a higher lift, higher drag, lower drag. What is the case? Yeah, it is
Higher
going to
lift and
have.
higher.
Yeah, why do you say so, Ali?
Option A, like higher lift and higher drag.
Yeah, why? What is the reason?
First point, like we have two wings, so that it will generate more lift compared to monoplane. And second one, uh, due to the uh, frontal area like that, it may experience high drag.
Very good. So see, ultimately, when you are exposing a body to the air, okay, and you have a flow over it, it generates lift. So you are exposing a surface area, right? So in the case of a monoplane, it is just one wing, and in the case of a biplane, you have two wings. So the surface area has now increased. So both the wings are going to produce lift. Okay, so this is going to produce more lift compared to monoplane. But what is the problem? Why did the aircraft, the first ever plane built by Wright brothers, fail? You know what was the flight duration for the first plane built by Wright brothers? For how much duration did it fly? And what happened? Does anyone know that? Yes, close to 13 seconds. So for those of others who have no idea, just go through it. Okay, just it's interesting to read how was the early development of aircraft design. So it started with Wright brothers. They built a biplane, and that could not sustain much because the weight was more, right? The Because you are using two wings, it is increasing to the it is increasing the weight of the complete body, right? And the drag was higher. Why was the drag higher? Because now you have more surface area. So when the air flows through a higher surface area, it obviously generates more drag. So it had a higher lift, but the drag was so much and the weight was so much, so it could not sustain a longer duration flight. Okay, so remember, to sustain a flight in equilibrium condition, your lift has to be equal to weight and your thrust has to be equal to drag. That is the cruise condition. We call it a steady level flight or constant altitude wings level flight. Okay, so that is when all your forces are in equilibrium. Okay, so when the equilibrium is disturbed, you will not sustain a cruise flight. I mean, it will not be a steady flight. Okay, so in the biplane, the drag was higher. So it has a higher lift and a higher drag. Okay, so is obviously a disadvantage. It is not aerodynamically efficient. When we talk about aerodynamic efficiency, there's a parameter which is called as L by D ratio. L by D is lift by drag ratio. We call it as aerodynamic efficiency. So for any body that flies, for an aircraft wing or for a rocket or for a missile, for any body that flies, your L by D has to be always greater than 1. Okay, so more your L by D, more aerodynamically uh, advantageous is the shape. Okay, so we always try to maximize our L by D ratio. So generally, if you look at airplane wings, the L by D is roughly around 10 to 15. Okay, so higher L by D, it is aerodynamically advantageous, but there are also other problems. So aircraft design is always compromise between various factors. It is not that I'm an aerodynamic engineer, I'll make a very efficient wing, I'll make a long wing which can produce very good lift, but it can have other problems. So there is structural problems, you have to fit the propulsion system, you have to have controls, right? So it is not easy to just look at one parameter and fix it. Okay, it's always an iterative procedure. All right, so is this clear, everyone? Is this clear? Okay, so yeah, that's all guys. There's one more question, but I'll not take it up now, uh, because we haven't covered a lot of things. So this was just for your uh, just for you, just a demo lecture for your experience. Okay, obviously when we go to regular classes we will start things from scratch. Okay, so yeah, that's it, thank you guys. And anything, any doubts you guys want to ask, please feel free. Yeah, any doubts? Okay, any feedback? How was the class? How was it?
Sir,
Yes.
sir, what is meant by the shape of the swift wing, sir?
uh See, swept wing is just that. So you have a rectangular wing, right? Rectangular wing is a very straight, simple straight wing. When that is
Yes,
inclined, okay, when that is kept at an angle to the fuselage center line, okay, that is known
yes,
as
sir.
swept wing. So you're sweeping it. Okay, what do you mean by sweep? You just make it at an angle. That is known as swept wing. Why do we sweep the wing? Is it has some stability advantages. So it enhances your directional stability, your roll stability. Okay, so when your aircraft undergoes a roll, it makes it to come back to its original position. So it is stable in uh, roll. Okay, so that is one of the advantages. There are other advantages also by using a swept wing.
Yes, sir.
Okay,
Yes, sir.
any other doubts? Okay, Hari Shankar. So you want to know more about me? We can probably have a detailed conversation later on. Okay. Thank you. Thank you, Dimanshu. Thank you. So yeah, that's all, guys. Uh, that's all from our side, and we will. So once we come to the regular classes, we will start off. And before that, you will have to cover some basic subjects. So the prerequisite for aerodynamics is fluid dynamics. Okay. So you will start with fluid dynamics. You'll understand the basic concepts, and then we'll start with aerodynamics. Okay, because aerodynamics is basically fluid dynamics applied to aircraft. Okay, so that has to be completed first, and then we will start this. Okay, all right.
Sir,
So
excuse me.
thank you, everyone. Yes, yes, Kiran.
So, what was the name of the book that you suggested for aerodynamics?
John D. Anderson, Fundamentals of Aerodynamics by John D. Anderson. So
Okay,
Anderson
sir.
is a very popular author in aerospace. He has written a series of books: aerodynamics, gas dynamics, aircraft design. The very simple book is Introduction to Flight, which you all should read. Okay, any aerospace engineer should start with that book. Okay, Introduction to Flight by John D. Anderson. It's a very interesting book. It gives you, uh, I mean, it has a multi-dimensional view of the complete aerospace engineering, of all the specializations. Okay, so it talks about all the basic concepts in a very layman term. Okay, so anyone can understand. It's not just that aerospace engineers, anyone can understand. So whenever you have time, please go through that. Okay. Kevin, do not worry about it now. As we start the classes, I'll start. I'll explain you. I'll tell you in detail what are the topics, what are the contents that we're going to discuss. Okay. So the syllabus is already there, so you can see the GATE syllabus downloaded from the website. Okay. Generally, it is the same. So the topics mentioned in the GATE syllabus are the topics, but still, okay, we are not only covering things for GATE. See, GATE is, of course, you all of you are here to clear that, but when we learn a subject we learn it from understanding point of view. So for me it is that how much of concepts that you have learned. So if you know the concept, you understand the concept, clearing it, and that too, aerodynamics is very easy. Generally they do not complicate the questions, it's very easy to score. You can score full marks. Okay, so if the concept understanding is good, then there will be absolutely no difficulty. Okay, so thank you all. We will meet when the classes start. Okay, so thank you. Bye.
You are currently the only person in this conference.